Hello. That's fine. Am I audible, sir? That's great, sir. Let me extend a warm welcome to you initially.
Yes, I can see myself. Oh, that's true. That's
So, welcome back, everybody. This afternoon, we are thrilled to host yet another thought provoking session, this time on a topic that truly opens the doors of quantum learning to everyone. We don't need to be physicists or mathematicians to start in quantum machine learning. Our guest for this session is joining us online all the way from Berlin on the occasion of Qiskit Fall Fest 2025 being hosted at Rgukt-Ap, Srikakulam. So please join me in warmly welcoming Dr. Frank Zickert, quantum algorithm engineer and trainer. Dr. Frank has been working at the intersection of quantum computing and machine learning for over 5 years, serving as a quantum algorithm engineer and trainer at PyQML since 2020. Through his work, he focused on many quantum concepts, practical and accessible for developers, students, and industry professionals alike. He holds a Ph.D. in Information Technology from Goethe University, Frankfurt, and a Master's in Banking and Financial Support Services from the Frankfurt School of Finance and Management. His strong technical and analytical foundation enables him to bridge the gap between classical computing, machine learning, and the quantum frontier. So, Dr. Frank is also a renowned author of the Hands on Quantum Machine Learning with Python series, Volume 1 Get Started, and Volume 2 Combinatorial Optimization, which together forms one of the most practical guides for anyone eager to explore the quantum machine learning without needing to master any theoretical physics first. His mission is clear, guys, to help enthusiasts, developers, and students become quantum machine learning practitioners regardless of their academic background. His approachable teaching style and step by step practical insights have already inspired thousands of learners across the world. So, without any further ado, let's all extend a very warm virtual welcome to Dr. Frank and hand over the session to him as he takes us through today's engaging topic. We don't need to be physicists or mathematicians to start in quantum machine learning. So, sir, the virtual dais is all yours.
Hello, thank you for the warm introduction. Um, I'm starting to share my screen. Just 1 second, please. Great. Can you see it?
Yes, sir, it's visible right now.
Okay. Okay, thanks. So, when you start learning about quantum computing, you will face many claims about the potential of this technology. Um, just a second. So, just have a look at what McKinsey, for instance, says. They say the emerging technology of quantum computing could revolutionize the fight against climate change, transforming the economics of decarbonization and becoming a major factor in limiting global warming to the target temperature of 1.5 degrees Celsius. And other sources, such as Forbes, seem to agree the application of quantum technologies could transform the energy industry and lead to cleaner energy with fewer emissions. Both of these sources are completely reputable, and the articles also suggest that they have been thoroughly researched. But they are not selling research results, they are selling hype. Big consulting firms, global magazines, major tech companies, they all repeat the same prophecy. Quantum computing will change everything for the better. But basically, their claims are worthless because they both fantasize about what quantum computing could enable us to do in the future. They're clever. They always use the word could. So technically, they're not making any false claims because without a doubt, new technology could lead us to all sorts of things. But of course, these hypesters know the power of words and that could will be interpreted as will. They do not even explain or prove why quantum computers will solve these problems. Their main argument goes something like this. We know that quantum computers are capable of solving difficult problems. And here's a list of problems that we have no idea of how to solve them. And that's why a quantum computer is the right tool. So if you listen closely, there is no how, just big words and shiny predictions. They thrive on your curiosity. They want you to be excited, not informed. And that's exactly where most beginners fall into the trap, between wonder and confusion. When you start exploring quantum computing, you enter a world of strange truths, a world where the line between fact and fiction is barely discernible. The simple reason for this is because quantum computing is still so poorly understood. But quantum computing will only change the world if people like you, programmers, engineers, data scientists, and students, learn how to use it properly. When we stop treating it like sorcery and start treating it like technology, not through mysticism, but through clarity, practice, and reason. And this is what today's talk should be about. How can we programmers, engineers, data scientists, and students learn quantum computing at all? So, if you really want to learn quantum computing, it's time you turn to more serious sources, like introductory courses. At first, the beautiful explanations of quantum mechanical concepts will cast a spell over you. A qubit can be both 0 and 1 at the same time. And you think, that's beautiful, that's elegant, that all makes sense. Finally, someone explains it understandably. They speak softly, clearly, and sound trustworthy, just like the sirens in Homer's Odyssey. As soon as you go into detail, they reveal their gruesome fates. Suddenly, the superposition is a two-dimensional quantum system that's usually denoted as a quantum state kept psi, such as a qubit, is a complex linear combination of its mutually orthogonal basis state vectors. And the sirens don't lie. They just leave out the important part. They replace understanding with metaphors and then abandon you. They don't say that a qubit isn't really both 0 and 1. It isn't in two states. It is in a particular quantum state that we just can't observe directly. They just leave you with Greek letters, vertical lines, strange symbols, and no explanation of their meaning. They skip right over the part where intuition fails. The sirens thrive on incomplete understanding, on that satisfying illusion that you almost understand. They make you feel smart just long enough until you feel stupid again. And then you start wonder, maybe you do need a degree in physics after all. Maybe you should go bridge between your own world and theirs. You find an impenetrable wall. You find only an alien landscape of symbols and assumptions. You calm down and accept